I bet you didn't know that Muslim scholars helped invent algebra and even figured out how we see. Pretty amazing, right? Meet al-Biruni, who measured the earth, al-Mawardi, who wrote about leadership and laws, and Ibn al-Haytham, the genius behind how light works, and Abu Ali al-Hussein ibn Sina, the master of philosophy and science. Their discoveries still help us learn today. Science is for everyone, including you. Abu Hassan ibn al-Haytham, 965, 1040 CE. Abu Ali Hassan ibn al-Haytham was one of the most eminent physicists whose contributions to optics and the scientific methods are outstanding. Known in the West as al-Hazan, Ibn al-Haytham was born in 965 CE in Basra and was educated in Basra and Baghdad. Thereafter, he went to Egypt, where he was asked to find ways of controlling the flood of the Nile. Being unsuccessful in this, he feigned madness until the death of Caliph al-Hakim. He also traveled to Spain, and during this period he had ample time for his scientific pursuits, which included optics, mathematics, physics, medicine, and development of scientific methods, on each of which he has left several outstanding books. He made a thorough examination of the passage of light through various media and discovered the laws of refraction. He also carried out the first experiments on the dispersion of light into its constituent colors. His book Kitab al-Manatir was translated into Latin in the Middle Ages, as also his book dealing with the colors of sunset. He dealt at length with the theory of various physical phenomena like shadows, eclipses, the rainbow, and speculated on the physical nature of light. He is the first to describe accurately the various parts of the eye and give a scientific explanation of the process of vision. He also attempted to explain binocular vision and gave a correct explanation of the apparent increase in size of the sun and the moon when near the horizon. He is known for the earliest use of the camera obscura. He contradicted Ptolemy's and Euclid's theory of vision that objects are seen by rays of light emanating from the eyes. According to him, the rays originate in the object of vision and not in the eye. Through these extensive researches on optics, he has been considered as the father of modern optics. The Latin translation of his main work, Kitab al-Manatir, exerted a great influence upon Western science, for example on the work of Roger Bacon and Kepler. It brought about a great progress in experimental methods. His research in catoptrics centered on spherical and parabolic mirrors and spherical aberration. He made the important observation that the ratio between the angle of incidence and refraction does not remain constant, and investigated the magnifying power of a lens. His catoptrics contain the important problem known as Al-Hazen's problem. It comprises drawing lines from 2 points in the plane of a circle meeting at a point on the circumference and making equal angles with the normal at that point. This leads to an equation of the 4th degree. In his book, Mizan al-Hikmah, Ibn al-Haytham has discussed the density of the atmosphere and developed a relation between it and the height. He also studied atmospheric refraction. He discovered that the twilight only ceases or begins when the sun is 19 degrees below the horizon, and attempted to measure the height of the atmosphere on that basis. He has also discussed the theories of attraction between masses, and it seems that he was aware of the magnitude of acceleration due to gravity. His contribution to mathematics and physics was extensive. In mathematics, he developed analytical geometry by establishing linkage between algebra and geometry. He studied the mechanics of motion of a body, and was the first to maintain that a body moves perpetually unless an external force stops it or changes its direction of motion. This would seem equivalent to the first law of motion. The list of his books runs to 200 or so, very few of which have survived. Even his monumental treatise on optics survived through its Latin translation. During the Middle Ages, his books on cosmology were translated into Latin, Hebrew, and other languages. He has also written on the subject of evolution, a book that deserves serious attention even today. In his writing, one can see a clear development of the scientific methods as developed and applied by the Muslims, and comprising the systematic observation of physical phenomena and their linking together into a scientific theory. This was a major breakthrough in scientific methodology, as distinct from guess and gesture, and placed scientific pursuits on a sound foundation comprising systematic relationship between observation, hypothesis, and verification. Ibn al-Haytham's influence on physical sciences in general, and optics in particular, has been held in high esteem, and in fact, it ushered in a new era in optical research, both in theory and practice. Abu al-Hasan al-Mawardi, 972, 1058 CE. Abu al-Hasan Ali ibn Muhammad, ibn Habib al-Mawardi, was born at Basra in 972 CE. He was educated at first in Basra, where, after completion of his basic education, he learned fiqh, Islamic jurisprudence, from the jurist Abu al-Wahid al-Samari. He then went to Baghdad for advanced studies under Sheikh Abd al-Hamid and Abdallah al-Baqi. His proficiency in jurisprudence, ethics, political science, and literature proved useful in securing a respectable career for him. After his initial appointment as Qadi, judge, he was gradually promoted to higher offices, till he became the Chief Justice at Baghdad. The Abbasid Caliph al-Qaim bi Amr Allah appointed him as his roving ambassador and sent him to a number of countries as the head of special missions. In this capacity, he played a key role in establishing harmonious relations between the declining Abbasid Caliphate and the rising powers of Buwahids and Seljuks. He was favored with rich gifts and tributes by most sultans of the time. He was still in Baghdad when it was taken over by Buwahids. Al-Mawardi died in 1058 CE. Al-Mawardi was a great jurist, muhaddith, sociologist, and an expert in political science. He was a jurist in the school of fiqh, and his book, Al-Hawi, on the principles of jurisprudence is held in high repute. His contribution in political science and sociology comprises a number of monumental books, the most famous of which are Kitab al-Ahkam al-Sultaniya, Qanun al-Wazara, and Kitab Nasihat al-Mulk. The books discuss the principles of political science, with special reference to the functions and duties of the caliphs, the chief minister, other ministers, relationships between various elements of public and government, and measures to strengthen the government and ensure victory in war. Two of these books, Al-Ahkam al-Sultaniya and Qanun al-Wazara, have been published and also translated into various languages. He is considered as being the author-supporter of the doctrine of necessity in political science. He was thus in favor of a strong caliphate and discouraged unlimited powers delegated to the governors, which tended to create chaos. On the other hand, he has laid down clear principles for election of the caliph and qualities of the voters, chief among which are attainment of a degree of intellectual level and purity of character. In ethics, he wrote Kitab Adab al-Dunya wa al-Din, which became a widely popular book on the subject and is still read in some Islamic countries. Al-Mawardi has been considered as one of the most famous thinkers in political science in the Middle Ages. His original work influenced the development of this science, together with the science of sociology, which was further developed later on by Ibn Khaldun. Abu Rayhan al-Biruni, 973-1048 CE. Abu Rayhan Muhammad ibn Ahmad al-Biruni was one of the well-known figures associated with the court of King Mahmud Ghaznawi, who was one of the famous Muslim kings of the 11th century CE. Al-Biruni was a versatile scholar and scientist who had equal facility in physics, metaphysics, mathematics, geography, and history. Born in the city of Keva near Ural in 973 CE, he was a contemporary of the well-known physician Ibn Sina. At an early age, the fame of his scholarship went around, and when Sultan Mahmud Ghaznawi conquered his homeland, he took al-Biruni along with him in his journeys to India several times, and thus he had the opportunity to travel all over India during a period of 20 years. He learned Hindu philosophy, mathematics, geography, and religion from three pandits to whom he taught Greek and Arabic science and philosophy. He died in 1048 CE at the age of 75, after having spent 40 years in thus gathering knowledge and making his own original contributions to it. He recorded observations of his travels through India in his well-known book, Kitab al-Hind, which gives a graphic account of the historical and social conditions of the subcontinent. At the end of this book, he makes a mention of having translated two Sanskrit books into Arabic, one called Sakaya, which deals with the creation of things and their types, and the second, Patanjal, dealing with what happens after the spirit leaves the body. His descriptions of India were so complete that even the Ain-e-Akbari, written by Abu al-Fadl during the reign of Akbar 600 years later, owes a great deal to al-Biruni's book. He observed that the Indus Valley must be considered as an ancient sea basin filled up with alluvials. On his return from India, al-Biruni wrote his famous book Qanun-e-Masudi, al-Qanun al-Masudi, fi al-Hayawa al-Nujum, which he dedicated to Sultan Masud. The book discusses several theories of astronomy, trigonometry, solar, lunar, and planetary motions and relative topics. In another well-known book, Al-Athar al-Baqiyah, he has attempted a connected account of ancient history of nations and the related geographical knowledge. In this book, he has discussed the rotation of the Earth and has given correct values of latitudes and longitudes of various places. He has also made considerable contribution to several aspects of physical and economic geography in this book. His other scientific contributions include the accurate determination of the densities of 18 different stones. He also wrote the Kitaba al-Saidana, which is an extensive materia medica that combines the then existing Arabic knowledge on the subject with the Indian medicine. His book, the Kitaba al-Jamahir, deals with the properties of various precious stones. He was also an astrologer and is reputed to have astonished people by the accuracy of his predictions. He gave a clear account of Hindu numerals, elaborating the principle of position. Summation of a geometric progression apropos of the chess game led to the number 1616 degrees. 1 equals sign 18, 446, 744, 073, 709, 551, 619. He developed a method for trisection of angle and other problems which cannot be solved with a ruler and a compass alone. Al-Biruni discussed, centuries before the rest of the world, the question whether the Earth rotates around its axis or not. He was the first to undertake experiments related to astronomical phenomena. His scientific method, taken together with that of other Muslim scientists, such as Ibn al-Haytham, laid down the early foundation of modern science. He ascertained that as compared with the speed of sound, the speed of light is immense. He explained the working of natural springs in artesian wells by the hydrostatic principle of communicating vessels. His investigations included description of various monstrosities, including that known as Siamese twins. He observed that flowers have 3, 4, 5, 6, or 18 petals, but never 7 or 9. He wrote a number of books and treatises. Apart from Kitab al-Hind, History and Geography of India, Al-Qanun al-Masudi, Astronomy, Trigonometry, Al-Athar al-Baqiyya, Ancient History and Geography, Kitab al-Saydana, Materia Medica, and Kitab al-Jawahir, Precious Stones. As mentioned above, his book Al-Tafhim li Awail Sina'at al-Tanjim gives a summary of Mathemat, ICS, and astronomy. He has been considered as one of the very greatest scientists of Islam, and all considered one of the greatest of all times. His critical spirit, love of truth, and scientific approach were combined with a sense of toleration. His enthusiasm for knowledge may be judged from his claim that the phrase Allah is omniscient does not justify ignorance. Abu Ali al-Hussein ibn Sina, 980-1037 CE. Abu Ali al-Hussein ibn Abdallah ibn Sina was born in 980 CE at Afshana near Bukhara. The young Abu Ali received his early education in Bukhara, and by the age of 10 had become well versed in the study of the Quran and various sciences. He started studying philosophy by reading various Greek, Muslim, and other books on this subject, and learnt logic and some other subjects from Abu Abdallah Natili, a famous philosopher of the time. While still young, he attained such a degree of expertise in medicine that his renown spread far and wide. At the age of 17, he was fortunate in curing Nu ibn Mansur, the king of Bukhara, of an illness in which all the well-known physicians had given up hope. On his recovery, the king wished to reward him, but the young physician only desired permission to use his uniquely stocked library. On his father's death, Bu Ali left Bukhara and traveled to Jurjan, where Khwarizm Shah welcomed him. There, he met his famous contemporary Abu Rayhan al-Biruni. Later he moved to Ray and then to Hamadan, where he wrote his famous book Al-Qanun fi al-Tib. Here he treated Shams al-Dawla, the king of Hamadan, for severe colic. From Hamadan, he moved to Isfahan, where he completed many of his monumental writings. Nevertheless, he continued traveling, and the excessive mental exertion as well as political turmoil spoilt his health. Finally, he returned to Hamadan, where he died in 1037 CE. In any age, Ibn Sina, known in the West as Avicenna, would have been a giant among giants. He displayed exceptional intellectual prowess as a child, and at the age of 10 was already proficient in the Quran and the Arabic classics. During the next 6 years, he devoted himself to Muslim jurisprudence, philosophy, and natural science, and studied logic, Euclid, and the Almagest. He turned his attention to medicine at the age of 17 years and found it, in his own words, not difficult. However, he was greatly troubled by metaphysical problems, and in particular the works of Aristotle. By chance, he obtained a manual on this subject by the celebrated philosopher Al-Farabi, which solved his difficulties. By the age of 18, he had built up a reputation as a physician, and was summoned to attend the Samani ruler Nu ibn Mansur, reigned 976-997 CE, who, in gratitude for Ibn Sina's services, allowed him to make free use of the royal library, which contained many rare and even unique books. Endowed with great powers of absorbing and retaining knowledge, this Muslim scholar devoured the contents of the library, and at the age of 21, was in a position to compose his first book. At about the same time he lost his father and soon afterwards left Bukhara and wandered westwards. He entered the services of Ali ibn Mamun, the ruler of Khiva, for a while, but ultimately fled to avoid being kidnapped by the Sultan Mahmud of Ghazna. After many wanderings he came to Jurjan, near the Caspian Sea, attracted by the fame of its ruler, Qaboos, as a patron of learning. Unfortunately, Ibn Sina's arrival almost coincided with the deposition and murder of this ruler. At Jurjan, Ibn Sina lectured on logic and astronomy and wrote the first part of the Qanun, his greatest work. He then moved to Ray, near modern Tehran, and established a busy medical practice. When Ray was besieged, Ibn Sina fled to Hamadan, where he cured Amir Shamsud-Dawla of colic and was made prime minister. A mutiny of soldiers against him caused his dismissal and imprisonment, but subsequently the Amir, being again attacked by the colic, summoned him back, apologized, and reinstated him. His life at this time was very strenuous. During the day he was busy with the Amir's services, while a great deal of the night was passed in lecturing and dictating notes for his books. Students would gather in his home and read parts of his two great books, the Shifa and the Qanun, already composed. Following the death of the Amir, Ibn Sina fled to Isfahan after a few brushes with the law, including a period in prison. He spent his final years in the services of the ruler of the city, Ala al-Dawla, whom he advised on scientific and literary matters and accompanied on military campaigns. Friends advised him to slow down and take life in moderation, but this was not in character. "I prefer a short life with width to a narrow one with length," he would reply. Worn out by hard work and hard living, Ibn Sina died in 1036/1 at a comparatively early age of 58 years. He was buried in Hamadan, where his grave is still shown. Al-Kifti states that Ibn Sina completed 21 major and 24 minor works on philosophy, medicine, theology, geometry, astronomy, and the like. Another source, Brockelman, attributes 99 books to Ibn Sina, comprising 16 on medicine, 68 on theology and metaphysics, 11 on astronomy, and 4 on verse. Most of these were in Arabic, but in his native Persian he wrote a large manual on philosophical science entitled Danish Nama-i-Ale, and a small treatise on the pulse. His most celebrated Arabic poem describes the descent of soul into the body from the higher sphere. Among his scientific works, the leading two are the Kitab al-Shifa, Book of Healing, a philosophical encyclopedia based upon Aristotelian traditions, and the Al-Qanun al-Tib, which represents the final categorization of Greco-Arabian thoughts on medicine. Of Ibn Sina's 16 medical works, 8 are versified treatises on such matter as the 25 signs indicating the fatal termination of illnesses, hygienic precepts, proved remedies, anatomical memo, randa, etc. Amongst his prose works, after the Great Qanun, the treatise on cardiac drugs, of which the British Museum possesses several fine manuscripts, is probably the most important, but it remains unpublished. The Qanun is, of course, by far the largest, most famous, and most important of Ibn Sina's works. The work contains about 1 million words, and like most Arabic books, is elaborately divided and subdivided. The main division is into 5 books, of which the first deals with general principles, the second with simple drugs arranged alphabetically, the third with diseases of particular organs and members of the body from the head to the foot, the fourth with diseases which, though local in their inception, spread to other parts of the body, such as fevers, and the fifth with compound medicines. The Qanun distinguishes mediastinitis from pleurisy and recognizes the contagious nature of phthisis, tuberculosis of the lung, and the spread of disease by water and soil. It gives a scientific diagnosis of ankylostomiasis and attributes the condition to an intestinal worm. The Qanun points out the importance of dietetics, the influence of climate and environment on health, and the surgical use of oral anesthetics. Ibn Sina advised surgeons to treat cancer in its earliest stages, ensuring the removal of all the diseased tissue. The Qanun's Materia Medica considers some 760 drugs, with comments on their application and effectiveness. He recommended the testing of a new drug on animals and humans prior to general use. Ibn Sina noted the close relationship between emotions and the physical condition, and felt that music had a definite physical and psychological effect on patients. Of the many psychological disorders that he described in the Qanun, one is of unusual interest, love sickness. Ibn Sina is reputed to have diagnosed this condition in a prince in Jurjan who lay sick and whose malady had baffled local doctors. Ibn Sina noted a fluttering in the prince's pulse when the address and name of his beloved were mentioned. The great doctor had a simple remedy: unite the sufferer with the beloved. The Arabic text of the Qanun was published in Rome in 1593, and was therefore one of the earliest Arabic books to see print. It was translated into Latin by Gerard of Cremona in the 12th century. This canon, with its encyclopedic content, its systematic arrangement and philosophical plan, soon worked its way into a position of preeminence in the medical literature of the age, displacing the works of Galen, al-Razi, and al-Majusi, and becoming the textbook for medical education in the schools of Europe. In the last 30 years of the 15th century, it passed through 15 Latin editions and 1 Hebrew. In recent years, a partial translation into English was made. From the 12th to 17th century, the Qanun served as the chief guide to medical science in the West and is said to have influenced Leonardo da Vinci. In the words of Dr. William Osler, the Qanun has remained a medical Bible for a longer time than any other work. Despite such glorious tributes to his work, Ibn Sina is rarely remembered in the West today, and his fundamental contributions to medicine and the European reawakening goes largely unrecognized. However, in the museum at Bukhara, there are displays showing many of his writings, surgical instruments from the period, and paintings of patients undergoing treatment. An impressive monument to the life and works of the man who became known as the Doctor of Doctors still stands outside Bukhara Museum, and his portrait hangs in the hall of the Faculty of Medicine in the University of Paris. One of the 4 parts of this work is devoted to mathematics and Ibn Sina includes astronomy and music as branches of mathematics within the encyclopedia. In fact, he divided mathematics into 4 branches: geometry, astronomy, arithmetic, and music, and he then subdivided each of these topics. Geometry he subdivided into geodesy, statics, kinematics, hydrostatics, and optics. Astronomy he subdivided into astronomical and geographical tables and the calendar. Arithmetic he subdivided into algebra and Indian addition and subtraction. Music he subdivided into musical instruments. The geometric section of the encyclopedia is, not surprisingly, based on Euclid's Elements. Ibn Sina gives proofs, but the presentation lacks the rigor adopted by Euclid. In fact, Ibn Sina does not present geometry as a deductive system from axioms in this work. We should note, however, that this was the way that Ibn Sina chose to present the topic in the encyclopedia. In other writings on geometry he, like many Muslim scientists, attempted to give a proof of Euclid's 5th postulate. The topics dealt with in the geometry section of the encyclopedia are lines, angles and planes, parallels, triangles, constructions with ruler and compass, areas of parallelograms and triangles, geometric algebra, properties of circles, proportions without mentioning irrational numbers, proportions relating to areas of polygons, areas of circles, regular polygons, and volumes of polyhedra in the sphere. Full details are given in. Ibn Sina made astronomical observations, and we know that some were made at Isfahan and some at Hamadan. He made several correct deductions from his observations. For example, he observed Venus as a spot against the surface of the sun, and correctly deduced that Venus must be closer to the Earth than the Sun. This observation and other related work by Ibn Sina is discussed in. Ibn Sina invented an instrument for observing the coordinates of a star. The instrument had 2 legs pivoted at one end. The lower leg rotated about a horizontal protractor, thus showing the azimuth, while the upper leg, marked with a scale and having observing sights, was raised in the plane vertical to the lower leg to give the star's altitude. Another of Ibn Sina's contributions to astronomy was his attempt to calculate the difference in longitude between Baghdad and Gurgan by observing a meridian transit of the moon at Gurgan. He also correctly stated, with what justification it is hard to see, that the velocity of light is finite. As Ibn Sina considered music as one of the branches of mathematics, it is fitting to give a brief indication of his work on this topic, which was mainly on tonic intervals, rhythmic patterns, and musical instruments. Some experts claim that Ibn Sina's promotion of the consonants of the major third led to the use of just intonation rather than the intonation associated with Pythagoras. More information is contained in T.S. Visgo's paper on Ibn Sina's contribution to musicology in. Mechanics was a topic which Ibn Sina classified under mathematics. In his work Miyar al-Aqul, Ibn Sina defines simple machines and combinations of them, which involve rollers, levers, windlasses, pulleys, and many others. Although the material was well known, and certainly not original, nevertheless, Ibn Sina's classification of mechanisms, which goes beyond that of Heron, is highly original. Since Ibn Sina's major contributions are in philosophy, we should at least mention his work in this area, although we shall certainly not devote the space to it that this work deserves. He discussed reason and reality, claiming that God is pure intellect and that knowledge consists of the mind grasping the intelligible. To grasp the intelligible, both reason and logic are required. But, claims Ibn Sina, it is important to gain knowledge. Grasp of the intelligibles determines the fate of the rational soul in the hereafter, and therefore is crucial to human activity. Ibn Sina gives a theory of knowledge, describing the abstraction in perceiving an object rather than the concrete form of the object itself. In metaphysics, Ibn Sina examined existence. He considers the scientific and mathematical theory of the world, and ultimate causation by God. His aims are described in as follows. Ibn Sina sought to integrate all aspects of science and religion in a grand metaphysical vision. With this vision, he attempted to explain the formation of the universe, as well as to elucidate the problems of evil, prayer, providence, prophecies, miracles, and marvels. Also, within its scope fall problems relating to the organization of the state in accord with religious law and the question of the ultimate destiny of man. Ibn Sina is known to have corresponded with al-Biruni. 18 letters which Ibn Sina sent to al-Biruni in answer to questions that he had posed are given. These letters cover topics such as philosophy, astronomy, and physics. There is other correspondence from Ibn Sina which has been preserved, which has been surveyed in the article. The topics of these letters include arguments against theologians and those professing magical powers, and refutation of the opinions, those who having a superficial interest in a branch of knowledge. Ibn Sina writes on certain topics in philosophy, and writes letters to students who must have asked him to explain difficulties they have encountered in some classic text. The authors of Ibn Sina as promoting natural science and arguing against religious men who attempt to obscure the truth.